Hello everyone, welcome to RoArm, a dedicated YouTube channel for robotics and automation. In this channel, we'll provide informational, in-depth and professional video tutorials at regular intervals. Please subscribe and visit this channel for updates on robotics and automation. Please comment below with topics of your interest to help you better and contact us with details given below for further information. Happy learning! Robots are very complex systems. They automate and emulate actions of physical world. Multiple engineering systems come together to build them. Broadly, basic building blocks of robotics and automation can be grouped under three categories. Robot structure gives the physical form to a robot and helps robot emulate real-world functionality. Structure gives the form and stability to a robot, whereas mechanics deals with the various moving parts of a robot. Electronics and electrical hardware essentially drives the robot structure. Hardware transforms the mechanics of a robot into electrical domain. It also lets software to drive the robot functionality. Hardware, in a way, becomes the interface through which the external world interacts with robots, including human beings. Software is the brain behind a robot. Without the software, robot will not function or not function as intended and can lead to hazards. Software gives users an easy way of configuring, deploying, and programming a robot to function in various roles. Having touched upon the basic building blocks, we now dive deep into software and programming aspects in this video. We will try to explain essential components and concepts of software in general, but also relate them to robotics in particular. Software enables us to enhance the functionality, configurability, and usability of a system. The software programming languages, along with operating system concepts, gives structure to the thought process and logic behind a robot's functionality. Operating systems abstract the interaction with hardware and help to reduce complexity and improve portability by managing resources and scheduling tasks. As applications of software are being vast, operating systems allows programmers to concentrate on a specific aspects of programming. Operating system provides consistent and standard interfaces to deal with other aspects of system as well. It is possible to develop system without operating system known as non-OS or bare metal system. Obviously, they tend to be simple systems and use low-level programming languages like assembly or C. Also, based on their applications, various kinds of soft and hard real-time operating systems are being used in products. Generally, the responsiveness of a system is called as real-time. Basically, how deterministic a system is to the external or internal events. Aptly, not responding to events within predetermined timelines is known as missing deadline or non-real time. In soft real time, missing the deadline has less severe consequences and still system is usable, but with a certain degree of temporary or permanent degrading of performance. Windows, Linux, and Android comes under soft real-time operating system category. Whereas in hard real-time, missing of the deadline has consequences and essentially renders the system unusable. Mucas2, QNX, VxWorks, and Green Hills are some of the hard real-time operating systems which can be programmed to achieve stringent deadlines. Now, let's discuss about robotic development platforms, which could speed up the development of robots by providing readily available software frameworks with supported robot structure and hardware. A Microsoft Robotics Developer Studio (MRDS) is a Windows-based robot control and simulation environment. Tools used for robotic application development are graphical environment using MPL, command line tools, Visual Studio projects using C# and 3D simulation tools. A robotic operating system ROS supports robotic development in Windows and Linux. Ubuntu Core is a Linux distribution for robotic development, can interact with ROS middleware. It has ready-to-interact components for all boards, applications, and frameworks. It supports building two-wheel, three-wheel, and four-wheel robots using Raspberry Pi, BeagleBone, and BeagleBone Blue boards. Also, HROS, a hardware robotics operating system, defines specifications for robotic parts supplied by various vendors. By putting them together, a robot can be built. ROS defines hardware systems in categories like sensing, actuation, communication, as well as cognition and hybrid components. In Windows, Robotics operating system is a browser-based development studio, so no installation required, which provides interface for launching robot operations with rich set of AI and cloud features. It provides readily available tools along with shareable, reusable robotic projects to create or enhance new or existing robots respectively. Android-based robots allows controlling of various robotic operations using Android apps. Android apps uses readily available interfaces like camera, BT, Wi-Fi, SIM network, and web tools available on handset or mobile to drive various robotic applications. Other RTOSs like Mucus2, QNX, VxWorks, and Green Hills with various single board computers support could be used for building robots as well. Programming languages helps us to talk with hardware at various levels. They enable programmer to think better and concentrate on developing an optimized algorithm for robotic applications. At a broad level, programming languages are classified as low-level and high-level languages. Low-level languages do not abstract the underlying hardware or CPU architecture over which they are executed. Typically, assembly languages fall into this category. Programmer needs to have in-depth knowledge of underlying architecture to write programs using assembly. On the other hand, high-level languages abstract underlying architecture and provide a set of consistent language features. Programmer can think at higher level and concentrate on application logic, whereas CPU architecture level aspects like converting high-level language to assembly code is done by compiler associated with them. High-level languages can be further classified as languages for system programming and work closely with processor architecture. Sometimes C and C++ are also called as mid-level languages, which are used in programming operating system core, including firmware, device drivers, and middleware layers. Although C++ has much wider applications than C language. Another classification of programming language is based on the programming paradigm they support. Procedural and object-oriented programs define different approach to problem solving. While procedural paradigm approach breaks down the problem into set of routines and data types, employing algorithm-based approach. On the other hand, object-oriented paradigm basically concentrates on data and defines objects which represent the real world. Objects define data and methods, where methods operate on data. Java, Kotlin, C#, Python, and VB belongs to this category. Another set of programming languages called scripting languages provide certain features for quick realization or validation of solutions. Scripting languages are generally interpreted. Python, Perl, Go, JavaScript, PHP are the widely used scripting languages. Some of the languages are best suited for embedded systems programming, like assembly, C, and C++, whereas some languages are best suited for web programming, like HTML or CSS, PHP, Java, JavaScript. Also, some languages are used for desktop or mobile application development like Python, Java, Android, Kotlin, VC++, VB, and C Sharp. Also, there are frameworks like .NET, Xamarin, QTRQML, Node.js, Angular, and Django to cater to these areas of applications. Various complex and advanced robots involve technologies like multimedia communication, VA, AIML, and IoT. Multimedia communication plays a vital role in identifying real-time objects and take their pictures and videos of different size and format. These pictures and videos are required for decision making and also identifying or debugging failures. Processed data can also be streamed to a centralized server for monitoring. Multimedia communication is used in agriculture, surveillance, entertainment, gaming, and military applications. Voice assistance is one of the important features of robotics and automation. With VA, users need not understand robotic commands and read product manual in order to interact with them. Robot with VA capability could understand commands or instructions from user in their natural and regional languages. This enables user to have pet robots, assistant robots, educational robots, servant and therapist robots to understand user commands and feelings to serve them better. Artificial intelligence and machine learning required for next generation robots, where robots would learn from the failures and adapt to the new learning. They learn and adapt to the real-time situations dynamically. The advantages of such technologies are you need not teach and recreate real-time scenarios where robot failed. Algorithms used in AML could empower robots to adapt and overcome new challenges at runtime. Internet of Things IoT with robotics called as IoRT, that is Internet of Robotics and Things, is used to connect embedded systems with robots. Multiple devices connected with different robots could be monitored, controlled, and diagnosed from cloud using IoRT. Industrial IoT, that is IIoT, plays vital role in factory automation using collaborative robots. Also, a set of semi-automatic and autonomous robots can be used as servant robots in hotel, disinfectant robots in officer malls, soldier and bombing robots in military applications, assisting doctors in complex operations, attending patients suffering with highly contagious diseases like corona, Ebola, etc. Software development tools involves IDEs with editor, preprocessor, assembler, interpreter, compiler, optimizer, linker, loader, simulator, and debugger with respective controllers support for simulating registers and loading startup codes. IDEs provide one-point solution for programmer to write, edit, compile, flash, and run code on the respective hardware selected by user. It also provides disassembly window, watch window, memory window, register window, and real-time object viewers to debug code while it is running on CPU by using in-circuit emulator or JTAG. Emulators such as in-circuit emulators used to debug software running on bound processor, whereas JTAG emulator is used for on-chip debugging with standard production chips. There are also terminal emulators such as PuTTY or TerraTerm for Windows, Minicom for Linux, Xterm or Genome for X Windows and Wayland, ZTerm or Mac Terminal for Mac OS. Also, there are ARM emulators such as ARMware or QEMU. That brings us to the end of this video. We thank you for visiting this channel and watching this video. Please subscribe to this channel to get updates of new videos in your inbox directly. Keep visiting this channel and keep learning.